if you're going to experiment with switch mode power supplies, you're going to need a square wave signal generator. Now you can build your own, but why not use the control chip that's made for that purpose, like TL494. First I'm going to show you what I've made, then we're going to talk about some physics. So I made this circuit on the breadboard just to test my schematic. It's a standard TL494 circuit. This is the chip TL494 right there. As you can see, works. I can control the frequency. I can control duty. Dead time. So I made this on the breadboard just to test if it works. As you can see, I've attached the battery with some double-sided tape and some copper clad. But like this, it's not very reliable and it's not suitable for further experimentation. So using this schematic, I've made the PCB. So this is the PCB version. It's not the best work, but it's much more reliable than the breadboard implementation. And so this one I'll be using for further experimentation with switch mode power supplies. This is the power input or the battery. This is the output. So here I can control the dead time, the duty cycle and the frequency. And here with the switch I can choose between parallel or push-pull operation. As you can see here, this is the push-pull operation, this is the parallel operation. This is the duty cycle control. This is the dead time control. So this formula here says that permeance is 1 over reluctance. Permeance is magnetic conductance and reluctance is magnetic resistance. So magnetic conductance, P, is 1 over magnetic resistance. This magnetic conductance summarizes the properties of the core. It can be measured or it can be calculated from other properties of the core like area, length, and other properties. If you have a core, magnetic core, with a known AL, you can make an inductor from it and you can calculate the inductance by multiplying AL with a number of turns squared. So if you're making a transformer, how do you calculate number of turns per 1 volt? Well, it's called the transformer equation, and it's derived from Faraday's law. And you can see it here. Since you're making a power supply, it's pretty important to know how to calculate the power. So these are the equations for power. Since this L is in the denominator, you can gap the core to increase power of your power supply. If you like this video, please like, subscribe, and thank you for watching.